Okay, thanks, Ramona. I'm going to be talking about oak systems. And I want to thank Amarina and Chris for inviting me to join the symposium to talk about oaks. I've started to become interested in oaks in particular because of my involvement with tribes who are really concerned about restoring these trees. And for this talk, I enlisted some help from Yana Valachovic with UC Extension, Cooperative Extension, and also got some photo from various colleagues who are shown in the lower right. And for context, this map shows the distribution of oak forests and woodlands in California. I'm going to feature examples from different parts of the state, although most of my work is in the mountain regions. And I'm going to visit similar maps in the context of climate change shortly. Oaks are a very interesting species or group of species to work with in terms of drought because they have adaptations that help them to withstand drought and drought-related wildfire disturbances. Some species are deciduous and can drop their leaves in droughts. The evergreen species have leaves that help them conserve moisture. Oaks have deep tap roots and form mycorrhizal associations that help them persist during droughts and in marginal soils. And the photos show how they can resprout following disturbance up top. And on the bottom is showing how oak leaf litter is more flammable than competing species. So when fires come through, that can help reduce competition from other species. And I'm playing on the title of Sergio Leone's classic film, The Good, the Bad, and the Ugly, for a second to think about the different ways that drought may affect oaks. So we can think about good effects in terms of actually being restorative for the system and adaptive to climate change. But we can also imagine bad effects in terms of degradation and especially loss of important ecosystem services. And then increasingly, I think we're confronting ugly effects where there's synergistic effects of different stressors, drought, wildfire, insects, and disease. And I'm thinking that ugly may be appropriate when we have drought effects that would normally be restorative, but because of these synergies, they're going to have more damaging effects. So thinking about the good, drought can help to restore balance to overgrown forest, and oaks may benefit in particular when conifers die during droughts. I'm going to highlight some examples from the Southern Sierra that Chris had talked about earlier. Yana has mentioned that she's seen flat-headed fir borer take out large conifers, and that can help release oaks in some areas. This insect usually attacks trees in poor vigor, resulting from either mechanical injury, mistletoe infection, fire damage, or drought stress. So these are examples of insects that have a regulating service, and they may be taking advantage of droughts. And that could in turn benefit oaks and the overall system resilience. But premature loss of especially mature oaks can be particularly bad from an ecosystem services perspective, since they support old forest wildlife species like fisher, and they're tremendously important to Native Americans who depend on harvesting acorns as a traditional food. So one goal is to conserve groves where families have gathered for generations through active restoration treatments. So I'll be closing with some strategies that talk about that approach. And increasingly across different regions of California, we're confronting the combination of drought with other stressors, including wildfires throughout the state, the introduced pathogen sudden oak death in the Coast Range, and insects like gold-spotted oak borer in the Southern Range. And to return to the idea of potential good effects of drought, some earlier work by Bill Ticha studied drought from 1998 to 1992, and they described this drought as the worst the state had experienced that century, and they noted it was especially severe on the Central California coast. But the general description of what they saw was an example of a system that was self-regulating. They noted that it was tending to cull smaller trees on poorer sites, like steep terrain, shallow soil, southern exposure. So they described that as possibly nature's way of regulating the distribution and abundance of oaks in California. And we can see examples, especially up in Northern California, with Oregon white oak, California black oak woodlands that have experienced significant declines over the last 100 years due to conifer encroachment, which was exacerbated by fire suppression. And that encroachment has been associated with wet periods over the last century. So to the extent that drought can help restore some of that balance where we've had the conifer encroachment, that could be a restorative effect. And then when we look at climate change modeling, its projected changes in habitat for various oak species over time. These figures are examples for 3 species. The California black oak is focused in on the southern Sierra Nevada. The other 2 are California wide, and these are just examples of maps. But in general, most maps like these of future projections of oak expansion or persistence or contraction show the same patterns of oak expansion in the northern areas and at higher elevations, and contraction in the southern areas, especially down in Southern California and at lower elevations. And a study published last year by Luke Brown and my colleague Jessica Wright found that valley oak, they looked at genetics of valley oak around the state, and they found that the valley oaks will be challenged as temperatures rise over the next century. So kind of reinforcing these modeling projections. And folks from our aerial detection program, the Forest Service, have been monitoring oak mortality, especially down in Southern California, showing both recent oak mortality and older mortality. And there's multiple disturbances at work in this region, including wildfires, drought, and insects. And one of those insects that's become more significant in these national forests in Southern California is the gold-spotted oak borer, which has come into the region from Arizona and is adding to mortality. Managers are currently working to protect high-value trees in areas with lower levels of infestation, and they're limiting the collection and removal of oak from the landscape, including in vegetation management projects. Another novel stressor in California oaks is sudden oak death in the northern and central California coastal region. It's heavily impacting tan oaks and coast live oaks in particular, and it interacts with climate change, insects such as the ambrosia beetle, and fire. And the combined effects are increasing the likelihoods of important shifts in composition. In the past, the wet winters would help to offset a dry year, but with sudden oak death, wet years increase oak mortality, and that has potential to increase fuel loads from dead trees. And then when dry years do occur, the ensuing wildfires can be more intense. So this illustrates how the natural restorative effects of drought may be altered when they're interacting with some of these other stressors, like introduced pathogens. Turning next to the southern Sierra Nevada, we see ecosystems that were heavily impacted by a record drought in recent years. And this is a map showing conditions in 2015. But that drought killed millions of trees across California, particularly in the southern Sierra Nevada. And the Sierra Nevada National Forest was a particularly hot zone, especially in 2016. It had a large percentage of all the dead trees in the state. This picture shows living oaks within stands of live, dying, and dead conifer trees. So again, there's potential for oaks to actually do well under these kind of conditions. However, in the southern Sierra Nevada, it's notable for the impacts to conifers, especially pines. I think Chris featured some slides showing that. But aerial surveys during that period also reported examples of extensive mortality in live oak and blue oaks. This is an area east of Fresno at lower elevation. So this may be showing how these projections for climate change are playing out on the ground. Higher up in the forest, where the conifers and oaks are mixed, we can consider whether drought may enable oaks to become more dominant where overstory pines have died. But we also need to factor in the competition from other conifer trees, the more shade-tolerant species like incense cedar and white fir. A study led by UCANR across the Sierra-wide network of regeneration monitoring sites found very low counts of pines or oaks compared to those shade-tolerant species in 2018. The oaks are in the kind of light green color, and the pines are in the darker green color, and the shade tolerance are in the pink color here. And then a related study published earlier this year found that in drought-affected areas that have been treated with thinning, oaks increased from, in terms of relative abundance, from 9 to 32%. And they were dominating the regeneration in these treated stands. And so that suggests that the effects of drought will depend on how we treat the forest. So we also need to consider the interactions with fuels. To the extent that we're shifting these forests toward oak conditions or oak dominance, we may be increasing the amount of oak litter, and that could have beneficial effects in terms of promoting a more natural fire regime. But we also have to consider the effects on the woody fuels. And so to the extent that drought is creating larger amounts of woody fuels, and this is that study from Young et al. Again, showing the down fuels in treated and untreated stands where you have very high loads in untreated stands. And there's certainly been discussion about how that could really intensify the severity of wildfires when they come through. And a lot of people are pointing to the creek fire as a potential example of where that's happening. And so there's certainly going to be a lot of close looking at the effects of that fire. And the concerns are, even though oaks may have been doing well as a result of the drought mortality, if we intensify the wildfires, the oak response may be impacted more as a result of that high severity fire. So I'm going to shift now to some strategies for how to deal with these drought effects. The first slide here is focusing on oak woodlands, which are featured in the Managing Effects of Drought in California report. And it talks about a number of strategies, including managing the understory to promote native grasses and oak seedlings. Although my colleague Yana notes that in her research in her region, they haven't seen a major effect of livestock grazing on oak survival, but instead deer browse has been an important factor. And so that's something to consider in different local areas, how the species are responding to browsing and grazing. And I know that deer browsing has also been a big issue in the Yosemite Park region. And looking at strategies for oak woodlands and forest, in their report, they certainly emphasized prescribed burning and mechanical thinning, and that also extends to management of oak forest. The oaks are doing that to reduce stand densities, to alleviate the risk of high severity fire, to create gaps to regenerate seedlings, and to reduce conifer encroachment. And this kind of approach is taking off in different parts of the state. And a good example is with the Western Klamath Restoration Partnership, where they're using prescribed burns in a tan oak stand in the center here. And then this is a very recent photo of thinning around black oak to remove young conifers. And it's notable that local environmental groups are supporting this work, even though in some cases they're removing some larger conifers. And this is another example from the WKRP of a shaded fuel break in a tan oak forest, where they're trying to promote multiple objectives, including reducing fire risk and promoting tribal harvest of acorns. So in general, there's growing attention to restoring cultural practices of Native Americans in oak systems, including cultural burns like this on the right, a recent example near Maricopa, led by Ron Good of the North Fork Mono Tribe. These burns are designed to promote many objectives, including large oaks with broad crowns. And more generally, prescribed burns can achieve similar goals to what the tribes are interested in promoting. Research by my colleague Carl Skinner and a study by Danny Fry showed that prescribed fires generally maintain oak crowns and can promote acorn production. And Chris had pointed out that Malcolm North's work has talked about using more intensive naturally ignited fires or more intense prescribed burns. And I guess the one concern there is safeguarding and inventorying, especially old and large legacy trees or groves that have been used by Native Americans, especially since returning fire into those stands can raise the risk of loss of those older trees, especially as fire creeps into the old burn scars. And that's my presentation. I want to thank you for viewing. On the right are some of the references I've included in my talk, and I can come back to that if anyone needs it. But I want to say thanks again to my colleagues, and I look forward to any questions after John speaks. Thank you.